Hello friends, welcome to my channel. In this video I will talk, you can see SANGER's methods of amino acid sequence determination from N-terminal end in a polypeptide. As you know, when we talk protein, we are talking that these are biopolymer, these are biomolecules, and these are biopolymer of monomer amino acid. Okay, so why amino acid sequence determination in a polypeptide is necessary, or what information it will give? Obviously, amino acid sequence determination or identification in a polypeptide will characterize the polypeptides, will identify the polypeptides and categorize, and also its post-translational modification. Okay, so this is the importance, that is, it will help in identifying a polypeptide, and it also categorize its post-translational modification. So when you if you are interested in history, you must know that first biochemist which is responsible for developing the method for amino acid sequence determination from N-terminal side is Frederick Sanger. He was British biochemist, and first of all he determined the amino acid sequence of insulin, and he also determined the first two amino acid from N-terminal side of insulin, that is glycine and phenylalanine. Okay, and in 1958 he was awarded Nobel Prize for his pioneer work. Apart from this Nobel Prize, he also won another Nobel Prize in 1980 in chemistry with two other gentlemen, that is Gilbert and Paul Burke, for developing determination of DNA sequencing. Okay, this used FDNB, that is 1-fluoro-2,4-dinitro-benzene, as its reagent for determination of amino acid sequence. So you can also call it FDNB. So you can see here FDNB, that is 1-fluoro-2,4-dinitro-benzene. Okay, that is your Sanger reagent, and you can see the structure here of FDNB, that is 1-fluoro-2,4-dinitro-benzene. So it is not as such that he directly reached at this reagent. Before that, he also tried methyl sulfonyl chloride and also dinitrochlorobenzene, that is chlorine at different position and nitro at different position of benzene nucleus. But in both the cases, he does not get the desired result. And finally, on the recommendation of one of his friend, he settled for this and found very good result. So what he did, he reacted the polypeptide with FDNB in presence of sodium bicarbonate solution at room temperature. It is very mild reactions at room temperature. Okay, and what will be the result? The product is 2,4-dinitrophenyl derivative of polypeptide. You will write the reaction. Right now what you see that what he did, he reacted with the given polypeptide, that is his insulin most of the time, you can see. So with sodium bicarbonate solution at room temperature, and he get 2,4-dinitrophenyl derivative of the polypeptide. And this 2,4-dinitrophenyl derivative of polypeptide is subjected further to hydrolysis, acidic hydrolysis. If you see, I have given in detail acidic hydrolysis in my video. Acidic hydrolysis with inorganic acid. Now here you have organic acid also, you have inorganic acid, but he did acid hydrolysis with inorganic acid, which leads to 2,4-dinitro derivative of N-terminal amino acid. That is first from N side, That is, if you are a polypeptide, N-terminal you know. So what is the N-terminal amino acid? Suppose you have like this. You have peptide. So what you have, you can see that this is a typical polypeptide. I have taken only the N-terminal amino acid. N-terminal amino acid. So what will happen? You will get a 2,4-DNP derivative of N-terminal amino acid, and also rest of the amino acid of the is also hydrolyzed because it is complete hydrolysis. So you will get mixture of different amino acid plus 2,4-DNP derivative of N-terminal amino acid. The reaction. Now you can see the reaction here. You have Sanger's reagent. So what you are doing, you are reacting the given polypeptide. You can see here it is the N-terminal, here is the C-terminal, in presence of sodium bicarbonate solution and at room temperature. And what you get this, that is 2,4-dinitrophenyl derivative of polypeptide. That is, the Sanger's reagent react with amino acid, first amino acid from the N-terminal end. Okay, and you get the corresponding 2,4-dinitrophenyl derivative, which is subjected to, as I told you, acidic hydrolysis by inorganic acid. And what you will get mixture of amino acid. A complete hydrolysis will take place, and you will get 2,4-dinitrophenyl derivative of amino acid. Which amino acid? Which is first from N-terminal end. You can see R1 is here, and you will also get mixture of amino acid because it is a complete hydrolysis. FDNB reacts with the N-terminal amino acid amino group. You see the reaction. Now what happens? You know, amino acid can be neutral, can be acidic, or can be basic. If you have more than one NH2 group, so if you have only one free amino acid in the N-terminal first amino acid, you will get monodinitrophenyl derivative. That is, you see, monodinitro amino acid derivatives are formed with free amino group. Okay, but if you have in case of basic amino acid, 2 amino group, so FDNB will react with both the NH2 group of the basic amino group. That is, one which is at the terminal end, and other which is lying other. Apart from that, it also reacts with thiol group and OH group. So what you can see, that it forms with lysine, tyrosine and cysteine, it forms dinitrophenyl amino acid derivative. Okay, so you can see the structure. Lysine, you have one NH2 here, one NH2 here. Now in cysteine you have a NH2, but you also have SH, and in tyrosine you can see you have NH2 and you have OH. So what happened? FDNB reacts also with OH group of tyrosine. Apart from the NH2 group, it also reacts with thiol group, okay, of cysteine, apart from the amino group. And lysine, obviously it has 2 NH2 free group, so it can be it will form dinitrophenyl amino acid derivative. Okay, now apart from these three, also FDNB, that is fluorodinitrobenzene, that is your Sanger's reagent, also react with imidazole decoylease of histidine to form dinitrophenyl derivative of amino acid. You see the structure of histidine here, you can see. So you have a free NH2 group, and apart from that you also have this H of the imidazole, which is obviously in resonance with these two nitrogen. Shifting of nitrogen takes place. So what happened? So in all the 4 cases, you will get dinitrophenyl amino acid derivative. Now, what is more interesting, that if you have lysine in the polypeptide chain somewhere, even it will react with FDNB. This will not react if it is not in at terminal position. But if you have lysine in a polypeptide, so even then, in between, not from the N-terminal side, that is from one end of the N-terminal, then what will happen? You can see lysine react with FDNB even if it is not present as N-terminal and first amino acid in given polypeptide. That is, in that case, it will form mono dinitrophenyl derivative. If it is not at the N-terminal, rather inside the polypeptide. A number of DNP amino acid derivative has been isolated and identified by using chromatography technique. It can be thin layer chromatography or partition chromatography and paper chromatography. Okay, but the drawback as far as of this SANGER method is that it cannot be used repetitively. That is, you will get only identification now of the amino acid which is at the N-terminal end. Okay, so why? Because a complete hydrolysis of polypeptide takes place and mixture of amino acid is obtained. So this is all about SANGER methods of determination of amino acid sequence from N-terminal end. Thank you.